Hello and welcome. My name is Dr. Lucie Guertault. I am an assistant professor in the BAE department. My expertise is in water resources engineering. We are here in the BAE teaching laboratory where you can see a lot of demonstrations and models. So we came with students here to do some experiments during classes to illustrate the concepts that we see in class. Today we're going to discuss the impact of hydraulic structures on the flow in rivers and streams. So I'm going to start with a little question for you. What do you think is the percentage of streams and rivers in the world that are not impacted by human activities? So we didn't put a dam on them or didn't build any bridge, didn't try to modify the shape of the river. The answer is between 2 to 3%. So it's a very small amount of rivers and streams that are not impacted by human activities. And if you look at any stream in Raleigh, it is impacted. We have built some bridges, we have maybe placed some culverts on them, and many streams in the area have also some reservoirs built on them. So you can see all of those dams that provide some flood control when there is a large storm that's coming. So today we're going to discuss what is the impact of hydraulic structures and in particular weirs on the flow. This is a hydraulic flume, so it's a very simple representation of a stream or river. You see it's a smaller scale, of course, and it has a simple geometry. It's the rectangle with the same material. Here we have plexiglass all along and the shape remains the same, the material remains the same. We can use it to test some designs and see how the designs will impact the flow. And there is a fantastic law in fluid mechanics that allows us to translate what we observe at the small scale to the larger scale, the real world practical scale. So the observations here, we can apply them to the real world after we do some experiments in the flow. So when we turn on the flow in the flume and there's no structure in it, you can observe that the water level is the same more or less everywhere. There are a few fluctuations and that can be caused by the roughness of the hooks that are in the flume, but also because of the disturbance that happens at the entrance of the flume and at the exit. But overall, the water level is the same, and that's what you will observe in a typical river where we didn't place any structure in it. So one example of hydraulic structure that is often used in streams and rivers, especially in stream restoration, is the weir. This is an example of weir, and the shape is called broad-crested weir. And we can place that in the river to protect the bed from erosion, but it also creates some changes on the flow patterns and allow us to control the velocities or the water levels in different locations of the river. So they're used a lot in stream restoration for protection against erosion, but they have other impacts as well, and we'll be able to discuss that once we put it in the flow. So in biological and ecological engineering, we are trying to design engineering solutions that are nature-based, or at least that provide some benefits to the ecosystem. And so we try to move away from using hard engineering structures such as the broad-crested weir and try to find other solutions that would provide some benefits in terms of water quality or aquatic habitat, for example. And an example of that would be to replace a broad-crested weir with a structure that will still provide the same benefit in terms of protecting the bed from erosion, for example, but will also provide additional benefits or limit some drawbacks in terms of fish passage, for example. We want to provide some benefits for the aquatic ecosystems, So providing fish passage will be an important aspect of it. The broad crested weir doesn't allow to do that, because if you remember, we had this waterfall happening at the downstream end, and the very fast velocities that would prevent fish from crossing the structure. So when we design structures to replace a broad crested weir and provide the same benefits for us humans, we need to think of additional parts of the design that will also provide, for example, fish passage. So we want some structures which has some openings in them and do not disturb the flow as much to provide opportunities for fish to cross the structure.